Hello, my name is Todd Gooch, and today I would like to address the American Chemical Society with the data that I presented at the San Francisco National Meeting earlier this year. In the case of alcohols, ketones, esters, ethers, aldehydes, and many other common functional groups and simple molecules like ethane, methane, etc., the standard model Lewis structures give exactly one structure for these functional groups and molecules. Gravitational unit theory molecular model Gooch structures give exactly one structure for these functional groups and molecules also. In the case of benzene, nitromethane, and many others, standard model Lewis structures must use two or more structures in order to represent the molecule. Benzene is a classic example because it has exactly two structures which are needed in order to represent the molecule. Alternating single and double bonds around the six-membered carbon ring were inadequate to describe the molecule after experiments showed by breaking each of the carbon-to-carbon bonds, it was found that there are equal energies on each of those bonds. So the stopgap measure of a circle inside of a hexagon was adopted in order to account for the observation. In the gravitational unit theory unified field theory model, there's exactly one structure only for benzene, and that structure shows equal energies on each of the carbon-to-carbon bonds. It's also able to show nitromethane with exactly one and only one structure and no resonance contributors or hybrids. Nitromethane is normally shown with its resonance contributors having charge, yet the molecule is known to be a neutral molecule. Using the Gooch structures, I have exactly one and only one molecule for nitromethane, and it shows a neutral molecule. It's absolutely amazing. In the case of molecules such as B2H6, B10H16, many others, standard model Lewis structures just simply cannot represent these molecules. The reason is because hydrogen has experimentally been found by the Nobel Prize winning work of Dr. Lipscomb in the mid-1900s that hydrogen is bonding to two boron atoms at the same time, and Lewis structures only show hydrogen with one bonding site, and therefore technically they cannot represent these molecules. What they're doing right now is using little dashes or dots in between the hydrogens and the borons in order to represent the molecule. They know the bond's there, but they have no way to describe it or represent it at all. Using the Gooch structures, I get exactly one and only one representation for these molecules. My hydrogen atom has two bonding sites and expects to bond to two atoms. My data is quite conclusive. The American Chemical Society should adopt my structures, and I recommend that they adopt my structures. This is my second video in my series on the periodic table, and I hope that you tune in for the rest of my series. Thank you very much for your time.